Okay, good morning everyone. Welcome to week 4 of our CCNA MOOC. This week we're going to look at some IP services and security, so mainly ACLs, a little bit of a look at NAT, some DHCP, and then some basic hardening principles. There'll be a fair bit of lab work today that I'll be doing through the Cisco online labs to get you a bit of a better look at those. And as I'll try and get through the theory as quickly as possible, just so we can spend as much time as we can actually on the lab, so you can see how these things work. I often think that, particularly with ACLs and that, sometimes it's good to have a look at the actual tables in memory of the router and some of the configuration commands. It'll give you a better idea of how these technologies actually work. And then when you come to the exam and you are asked to actually put in configuration commands, then you'll have some idea of what we can actually do. So access control lists, let's move straight into it. So ACLs are used for two purposes, mainly to restrict traffic or to identify traffic. And you'll see where that fits in as we move along. So an ACL is an ordered set of rules, basically. Each line in an ACL is called an access control entry, or an ACE. Okay, and you may be asked a question on that. And each line or access control entry will match a certain set of criteria. Okay, they are permit or deny based on this criteria. So when you're restricting traffic, it's permit or denied. When you're identifying traffic, permit basically means to include that traffic, or deny means to exclude it, so ignore it. Always remember that at the end of an access control list there is an implicit deny statement. So that's there always, and you cannot change that, cannot remove it. So if, for example, you write an access list that only denies traffic, effectively what you're doing is denying all traffic because of that implicit deny at the end. So always remember with your access control list you have to have at least one access control entry that permits some type of traffic for it to be useful. Okay, so the primary purpose is to filter traffic. Secondary is to identify. So the steps with this are we need to define some interesting traffic. Okay, so this can be interface to bring an interface up. Okay, so we've got interesting traffic. We want to bring our dial interface up, for instance. We want to encrypt some traffic. Okay, so we've got some traffic going across a link that needs to be encrypted, other that doesn't. We use an access list to identify that traffic and say that goes down the encrypted tunnel or it doesn't. And for policy routing as well. Okay, so some traffic we want to send out this interface, or everything else we want to send out through our internet link. Okay, as an example. So that's basically your identification. For interface up, to bring an interface up, encryption, policy routing, they're the three main ones that you would use. When you're peering with internet service providers or with other companies, you may want to identify routes to filter or allow in your routing updates. So you don't want to send them everything, you just want to send them part or a summarized version of what you've got on your internal network. So you use your access list to identify what you want to send. And then lastly, identify traffic for your quality of service policies. So for instance, QoS isn't a big concern on the CCNA exam, but just to break it down, generally you'll have multiple classes of traffic. So you may have voice, you may have video, you may have some other business critical traffic, and then you'll have your bulk stuff like your FTP and your web and your mail access, that sort of stuff. You use your access list to match that traffic, those different types of traffic, and then place them into the corresponding QoS queue. Okay, so you match on voice, you put in express forwarding. You match on your call signaling, you put it into AF31. Those sort of things. Okay, so you use a lot of ACLs in your QoS. Okay, so applying ACLs. When you're filtering, okay, so when you're using it as basically a sort of a firewall or a layman's version of protection, you apply those ACLs to interfaces, okay, in a certain direction. The ACLs are processed sequentially, okay, from top to bottom. So the first statement, if the traffic matches the first statement, that's whatever treatment you've given it there, whether it's a permit or deny, that's what will happen. Okay, it doesn't matter if it matches further down the list. Whichever rule matches first is how that traffic's going to be treated. So remember, they're processed sequentially. And of course, as I said before, there's that implicit deny at the bottom. the processing sequentially bit is important because if you have a number of different requirements, you need to make sure that you insert your rules into the ACL in an appropriate order. Okay, so say for instance you might say, all right, well I want all access to this particular web server to be denied, but then underneath it I want all other web traffic to be permitted. Okay, so if you put them around the other way, put those rules around the other way, all web traffic is going to be permitted. So you need to make sure that you've got them in the correct order for it to make sense. ACLs also have a direction, so inbound and outbound. So inbound means that it will check the ACL will be processed, excuse me, and the traffic will be checked before routing as the traffic goes into an interface. Okay, so before routing. Now, when we say into an interface, it doesn't necessarily mean coming from somewhere external into the interface. It could be coming from the router into the interface, but going in an outbound direction from the router, if that makes sense. Okay, so inbound just means that traffic's coming into the interface, not necessarily from physically outside the network. It could be from anywhere. And then outbound, that takes traffic as it goes out of an interface. Okay, not as it comes in, as it goes out, and that's done after routing. Now, there is only one ACL per interface, per protocol, per direction permitted at a time. So in other words, if you have a fast Ethernet interface, you can have an IP access list in an outbound direction and an IP access list in an inbound direction at the same time, but that's it. You can only have one per protocol, per interface, per direction at a time. Okay, ACL order. As I said before, carefully consider the order of the rules. Specific or frequently used rules should go to the top. Okay, so if you're saying from this host to this web server only on port 443, that's a very specific rule. Put it up the top. Okay, generic rules. Your rules should become more generic as you come down your list. Your new entries will always append on the bottom. So if you're configuring an access list and you had 10 rules and you leave it and then you come back the next day and think, oh, I've got to add another rule, you add it in, it will go to the bottom. Okay, and this is where Notepad is a great friend of ours. Okay, so typically what, it's not in any of the exam guides or specifically mentioned by Cisco or anything like that, but best practice in the industry is to use Notepad, and I'm sure most of you have probably used Notepad at one time or another. So grab your Notepad, copy your ACL configuration into your Notepad, make the changes, go back to your router, remove the access list completely, and then add it back in again with the new order. Okay, that's the safest, cleanest way to make sure that your ACLs are what you think they should be. Now, a little tip on that. If you're modifying an access list that could potentially cut you off from your device, make sure you remove it from the interface first. So take away the application of the ACL from the interface first before you change it. Because if you just go through the process I've just said with Notepad and you've left the ACL still applied to the interface, then as soon as you remove that ACL, you will lose access with most versions of iOS. So just be careful of it. And we'll see a bit of an example of that as we get to the lab. So types of ACLs, there are two main categories. There's the numbered ACLs, which are broken into ranges specific to each protocol. Okay, so as you can see here, the main ones you need to worry about are the IP ones. So numbered ACLs 1 to 99 are standard IP, and we'll see what that means in a minute. 100 to 199 are extended IP. And then there's now a standard IP expanded range, which is 1300 to 1999. So as you can see, a lot of access lists in there. And 200 to 2699 extended IP expanded range. That doesn't look right. So that should be 2000 to 2699. I was going to say that's a huge range. So I'll change that. 2000 to 2699 is the extended IP expanded range. Now, you can't remove individual lines from a numbered ACL. And again, this is where Notepad is really, really important. So most of our manipulation of our ACLs will come using Notepad or some other such program. I wouldn't recommend you use Word or any other mainstream word processing package, simply because they can embed carriage returns and line feeds in spots that you don't want them, and when you cut and paste it back into your console screen, you may get some undesirable results. And again, new entries go to the bottom. Okay, then there's named access lists. So they provide more flexibility. You can use descriptive names, so that's a good thing for your documentation. And when you're reading through, your access control list, sometimes you can go, if you've got heaps of ACLs on your routing, go, oh, ACL 100, what the heck is that for again? 101, what's that one for? Whereas you can actually give them descriptive names, so then it tends to make more sense. Individual lines can be removed. Okay, so you can actually go into the access list, in access list configuration, type no, whatever the rule is you want to take out, and it will move that line. Okay, but like numbered lists, all new entries are still added to the bottom, so you can't do anything about that. And then named access lists also come in two types. So you get your standard named access lists and your extended access lists. Okay, your wildcard masks. So ACLs use wildcard masks to determine which part of an address must match exactly and which part of an address can match any number. Okay, so this is opposed to a subnet mask, which tells us what part of an address is the network or the subnet and what part of an address is the host. So wildcard masks simply look like an inversed subnet mask. Oh, I'm going too fast there. Okay, so it's the opposite of a subnet mask. It looks like an inverse subnet mask. So for instance, 0.255.255.255 would be the standard, so to speak, wildcard mask for a Class A network. 0.0.255.255 would be the standard wildcard mask for a Class B, and 0.0.0.255 would be the standard one for a Class C network. Okay, so you can see they're basically the direct opposite of a normal subnet mask. So if we look at the example here, if we have the IP address 172.16.0.0 with a wildcard mask 0.0.255.255, this will match any address that begins with 172.16. Okay, so again, it's a direct opposite to the subnet mask. So in a subnet mask situation, if we had 255.255.0.0, that would say, okay, we know the network is 172.16, but we don't care what the other two octets are, they're applied to the host. In this case, it's a direct opposite. So this particular example will match on 172.16.anything.anything. So golden rules. If a bit is set to a 0 in a wildcard mask, the corresponding bit in the address must be matched exactly. So that's what we just saw. If a bit is set to a 1 in a wildcard mask, the corresponding bit in the address can match any number. And this is called the we don't care condition. Okay, we don't care what it is, it can be anything. So if we look at our 172.16 in binary, so we've got 101.01100, you can see there, and our wildcard mask, all zeros, 255.255, it will match. You can see when you do the math, comes down, doesn't change, so that must match exactly, but we don't care what is in the last two octets. Okay, so let's have a look at our lab example. So this is our example topology, 172.16.1.2/16, 172.17.1.1/16, and then router B, 172.17.1.2. So you can see they're on the same network, same Class B, they're on the same subnet, and then we've got two separate subnets. We've got a 16 subnet to the left of router A and an 18 subnet to the right of router B. So if we look at our syntax for a standard ACL, we have access list 1 to 99, remembering that's our standard for 1 to 99. Permit, deny, so permit or deny can be one or the other. We've got our source address, we've got our wildcard mask, and we've got our log. So you can see from that you can only match on source addresses. Okay, you can only match on source addresses for your access list, for your standard access list. Because of that, it's recommended that your standard access lists are applied closest to the destination network. Okay, closest to the destination network. So extended ACLs, if we have a look at our syntax for that, you can see it's quite a bit different. So we've got our access list 100 to 199, our number again, permit or deny again, protocol, so this can be IP, it can be TCP, or it can be UDP. Okay, source address, wildcard mask, destination address, wildcard mask, operator, which we'll have a look at the moment, port, so that you'd only use the port if the protocol was either TCP or UDP, obviously. If it was IP, you wouldn't need a port. And log option, which allows you to actually create a buffer inside the router, which will show you how many times that rule's been matched against. Okay, so the port operators. Okay. Let's have a look before we go into the port operators. Let's have a look at our lab. Okay, so filtering traffics with ACL. So again, I'm not necessarily going to run through this exact lab. We're just going to use the lab as an example. Okay, so as you can see, this one's got a bit of a different topology, so we're going to change that topology. Okay. So there's our first router. Get onto our branch router hopefully in a minute. There it is. Yep. Okay, so we're going to keep these routers nice and fresh. So while that's rebooting, if we just pop back to our topology over here, you can see our branch router will be router A and our HQ router will be router B. So what I'm going to do is I'm going to add some default configs into these routers, and then we're going to use them as our lab all the way through today. So this router, the HQ router, so the router on the right, the window on the right, is now just asking me about the initial configuration dialog. So I'm going to turn that off. I'm going to stop that. Okay, so and this router on the left, same again. Okay, so if you look at the window on the right will be router B, the window on the left will be router A. So I've got a configuration here that I created earlier. So going configuration T for config mode. I'm going to paste my configuration in again. Notepad's my friend. Okay, so what I've basically done there is I've applied the IP addresses. So if I run show IP int brief, you can see here that on Ethernet 00 I've applied 172.17.1.2, and then on the loopback, because I haven't actually got I don't want to use another physical interface, I'll just use a loopback. I've applied 172.18.1.1. and called it router B. So that is now router B on our right hand window. We will do the same on router A. Okay. Okay, and if I do a show IP int brief, so show IP interface brief, you can see I've done the same thing here. So we've got our Ethernet 0 interfaces. We'll be connecting our two hosts together, and our loopbacks will act as the left-hand interface on router A and the right-hand interface on router B respectively. So now if I just check that we've got our connectivity, well, that doesn't look good, does it? Something's not quite right there. Bear with me for a sec. That should be good by the look of that. So what is going on there? So there we go. We can go straight into the troubleshooting lab here. So let's have a look. Now the thing it could be is that the interfaces are not connected. Okay, so there you go. I've been dudded there. So what we've got is on the HQ router, I think we'll find. So what I'm doing here is trying to work out why these routers are no longer connected together. And I think what the trouble is that we've got the IP, I've put the IP address on probably on the wrong interface. So if we have a look at Ethernet 0/0 here, well first let's go into Ethernet 1 and we'll go no shut. Now we'll go no shut. So again, good troubleshooting process. So okay, so now Ethernet 0/1 has come up. So that automatically tells me that something is actually plugged into that interface. So we're going to go into Ethernet 0/0 and we're going to go no IP address. And we're going to go into Ethernet 1 and we're going to go IP address 172.17.1.1 255.255.0.0. Okay, and we see if we get any better luck on that. Look at that. I wonder if there's a problem with the lab today, or whether I'm just doing something crazy. 101. Okay. Bear with me for a second, guys. Apologies. That lab is not working for me today. So let's have a look at let's go to let's have a look at this guy here. So apologies for that. I'm not sure what's going on with that particular lab. When I ran through the test of it, it seemed to work fine. But that's a great thing about live lectures, is sometimes things don't go to plan. So let's have a look if we can find one that will go right for us. There we go. This one looks a bit better. Okay. So we'll see how we go here. So again, we're going to use the branch router as router A. And HQ router, sorry, what's it doing with you? and the HQ router is router B. Okay, let's see what these guys got configured on already. Okay, so we've got trunk. Okay, so we'll run those. Right, erase. Okay, so it's got Ethernet 1. So let's just work with that. So while that one's rebooting, we'll change our HQ router into router B. So show IP in brief, okay, shows us here. Now what I'm going to do while I'm waiting for this one to reboot, what I've done here is I've also, these commands here, these guys here, what that's done is that's gone into VTY line. So line VTY 0/4, space 4, refers to the incoming telnet lines, okay? And then on those incoming telnet lines I've said login local. So that's signifying to the router, use a local account to log in please. I've then created a username Cisco with the password Cisco up here, so I've enabled a user account in telnet, and if I now try to telnet to the loopback of this router from here, so 172.18.1.1, without the slash in it, you'll see it gives me a username prompt, Cisco username password, and I'm now on router B. So what I'm showing there is that telnet is enabled, okay? So now let's do the other router. So put it into enable mode. And we grab our configuration. And we paste that in. Now hopefully, unless there's something majorly going wrong today, we should be able to... What is going on? Well, that's hardly a good advertisement, is it? Something is majorly screwy this morning with our labs, which is not a good look. Let me just bring this one up. Oh, 0, 0. Can I ping itself? I can. Can I ping its neighbour? I can. Hey! Now we're good to go. Oh man, best load ports. Okay, there we go. Ah, that's why I switched. Trunk port. Silly me. Okay. Now we're right to go. So if we just clear this rubbish up off the screen so we can see. So we can see that if we have a look at our route table on here, on router A with the show IP route, we can see that we've got connected routes. And I've got to put a route back in because I changed the IP address interface. Oh, that's it. Okay, so you can see we've got a static route across to the other router there, so I can now, should now be able to ping, if we go back to our topology. Now I'm on router A, I should be able to ping 172.18.1.1. Oops, not with that address though. Okay, so I'm good. I can get all the way across from one side to the other. And then from router B, 172.16.1.2 is the far side address on router A. Good. Okay, so everything's working. Everything's nice. Now, let's say, for instance, that I'm here on router A. Can I telnet to router B? Typing out Cisco password. I'm now on router B. Okay, so I can telnet to router B. Great. What I want to be able to do is I want to be able to say, okay, well, anyone who's on router A, I want you to be able to ping through to router B, but I don't want them to be able to manage it. I don't want them to be able to access it. So remember I said before, we're using standard access lists. So remember I said before that you need to place your standard access list as close to the source as possible. So in this case, if I want to create a access list which stops access to router B, but I'm only using source addresses from router A, then I would put the standard access list as close as I can to router A. So in this case, on router A. So I'm going to create an access list which will prevent. Now at the moment it's a standard access list. Let's have a look at the syntax. Okay, so IP access list, we're going to use a standard at the moment. Okay, what's next? Now remember from our numbers, so we can put in a number, so anything from 1 to 99, so we'll just go 1. And that's it. Okay, so now we're into access list mode. You notice here that you could have put a word in, so that's your named access list. Okay, so standard keyword, standard named, standard number, standard name. Okay. Now what can we do here? So we use a question mark. Okay, so we can say, all right, well we want to deny anything from let's use a question mark. So let's deny anything from 172.16.1.2. Okay, so we're actually going to go from that particular host. Now, the other thing, there's two ways we can put in a host address. So what I'm going to do is I'm going to deny access from that loopback address on router A. There's two ways that we can do that. We can go 172.16.1.2 and then stick in the wildcard mask of all zeros, okay, which means that address now must match. The other way we could do it is by putting in the keyword host. Okay, so we could put in the keyword host and then 172.16.1.2, and you'll see something interesting here in a minute. Okay, so what else do we need to put? Okay, we can put the log keyword, which will make a list of how often that particular rule is hit, or we can just hit enter. I'm just going to hit enter at the moment. Okay, so we're denying 172.16.1.2. That's great. Now if I have a look at, if I come out here and I go show IP access lists, you can see there it is. So deny 172.16.1.2. Notice no wildcard mask. No, it doesn't need it. It knows it's a host, so it automatically does that. If we have a look at the run, so using a show run, and we just pop down to our access list again, see, it just subnet mask the wildcard mask is no longer there because it doesn't need it. Okay. Now, the next thing we do with that is we've now made our access list. Now we need to actually apply it somewhere. So if we look at our interface IP addresses, we can see that interface 01 is connected directly to our router B. So we need to apply our, not fast Ethernet, we need to apply our access list to 0/1. And we do that by using the access, okay, have a look, alright, IP first, and then we've got this access group command. Okay, so IP, I don't know if I spell it right, access group, let's have a look at what's next. Okay, then the number of the access list, which is 1. Is there anything else? There is, so an in or outbound, inbound or outbound direction. Okay, so in this case, because the router itself will be creating the packets, so in other words it's coming from the loopback interface, then we're going to set it in an outbound direction. Okay, so now we have that set in an outbound direction. If we have a look at show IP int E0/1, we will see we've got an outgoing access list is set to 1. Okay, so that's where we see that our access list is set to 1. Now, if I now try to ping from this router to the other router, okay, now, okay, here's a question for you. What's going to happen here? Is it going to work or is it not going to work? In this particular case, it's still going to work. Now, the reason it's still going to work is because when a packet is made from a router, made internally on a router like that one is, that's a ping packet made from the router, it will be sourced from the closest interface to its destination. So in this case, when I was sending that packet out, it was actually going out on the IP address on the Ethernet 01. Okay? Now, because in our access list I've actually matched on that address there, the loopback address, that one doesn't match, therefore it's allowed. Okay? But there's another interesting trick there, which hopefully you'll pick up on in a sec. So if I was then going to, if I want to ping to that address again, but this time I use the source address as loopback 0. Let's see what happens there. Okay, that still works. Okay, so why does it still work? And this is the trick I was just alluding to. Why does it still work? And this is something that, a bit of a trick that occasionally you'll see on the exams. Okay, so we've got deny 172.16.1.2, but it still works. Okay, if I use that source packet of there, loopback 0, wow, it still works. And it says I'm using the source address of 172.16.1.2. So shouldn't that actually be denied? Okay, let's just try something else. Let's see what happens here. Let's see what happens here. Because again, this is part of the troubleshooting process for access lists. Okay, so have a look. Ah, okay. This time it doesn't work. This time it stopped. This time it stopped. Okay, but what about if we just ping without the source loopback? What's going to happen then? So the idea of this, I just want you to get thinking about what's going on. Okay, so I see Christian's put in a comment which is spot on. He picked it up, so that's good. So first of all, the first reason it was working when it didn't look like it should work was because of the IP address being sourced from the 0/1 interface. Okay, so the closest interface will be sourced. The second time it worked from the loopback. Okay, so why did it work from the loopback? Well, the reason is because it's the packets are being initiated from the router. Now, the router already knows where destinations are, what it's connected to, where it can get to. Okay, the access list out, okay, works after routing has already been done. Okay, because it's been sent directly from the router out a connected interface, it just bang sends it out. Okay, so it overrules that. Whereas when we put it in the inbound direction, it's had to go into the logical interface inside the router. Okay, as it's coming into the interface, so before routing's done, it's going, oh, hang on a minute, I'm not going to allow that from the loopback, and it drops it dead. Okay, so what I'm trying to illustrate is that you've got to be very careful in the direction you put your ACLs in, and also the statements that you put in them. Okay, particularly if you're trying to block traffic that is initiated from the router itself, like Telnet, which is a valid concern, because there may be times when you're connected to provider networks or other networks and you don't want it to go back in. Okay, the other thing Christian made a note of is you would actually expect, and the reason why when I do this, okay, so I try to ping from 172.17.1.2, which is of course the Ethernet, which will be sourced from the Ethernet interface of router A, so 172.17.1.1. If I try to ping from there, it still gets blocked. And the reason is, as Christian brought up before, is because I haven't got a permit rule in my standard access list. So I've only put a deny in, and I said earlier that we need to have at least one permit. Okay, so the way you would do that, so the way you write that is deny from 172.16.1.2, but permit anything else. Okay, so if I go into there and I go IP access list standard 1, and I go permit any. Oh, sorry, I'm already into extended mode. Thank you. So we go permit, and we go any, because we don't need any, because we're only in a standard access list. And we have a look at show IP access list again. We see we have 2 statements in. Now what's going to happen here, do you think? So if we go into ping from the Ethernet interface, bingo, works. Okay, if we source it from loopback 0, it works again. Okay, see, interesting, isn't it? And this is because this is a problem with access lists on routers where you're trying to initiate and deny stuff from actually routers itself. Okay, so interesting behaviour, very, very interesting behaviour. So what I'm trying to illustrate here is you've really got to be careful what statements you put in, where you place these access lists, and in what direction you place them. So actually in this case, if we were to go back to the interface here, oh dear, fat fingers this morning. Okay, and we take off the IP access group, 1 in, take off in, whoop, oh, put an extra C in, my fat fingers. So access group 1 in, and access group out. Okay, so now we don't have it applied anywhere. So we go over to router B, and we create our access list. 1. What am I doing? Well, actually, you can do it. Access list standard 1. We're going to deny 172.16.1.2, and we're going to permit any. Okay. Then we're going to go into interface E0/0, and we're going to put in IP access group 1 in. Okay, so now we've gone to the other router and we've applied it on to the incoming interface on router B. So what difference is that going to make? Well, let's see. So if we just ping the loopback, for instance, over there, we know the route over there. Okay, so from the Ethernet interface, again, because I'm just pinging without a source interface, it's going to be sourced from the Ethernet interface, 172.17.1.1. If, however, I ping from the source of loopback 0, right, it still works. I'm a little bit worried about that. Ah, of course, so that still works. So why does that still work? I'm a silly noggin. Why does that still work? Let's have a look. Oh, don't tell me there's no debug ICMP. Okay, so anyone got any ideas why that would be? Let's have a look. Let's have a look. So we go back to here and we ping. And it said from source loop back 00. Let's have a look. See what happens. Okay, so what it's doing. It's saying echo reply sent source 172 destination 172.16.1.2. Okay, so that looks okay, doesn't it? Let's have a look. Alright. Ah, there you go. Very good. See? I've made there we go. So IP access group 1. Very good. So someone picked it up. It was going on the wrong interface. So okay, so there we go. So now we've got it. Have we got on the right interface? Now let's see what happens. 2.18.1, so again, sourced, and you can see it's coming from 172.17.1.1, so that's permitted, like we like. Now, let's see what happens if we go from source loopback 0. What happens there? Okay. Now showing up as undeliverable. Okay, and you can see on this side, on the router B side, we're administratively prohibited, unreachable. Okay. So what we're saying is, it's not that I can't route to it, so you're going to get a different result on your ping response. So in this case, what we're doing is we're saying administratively prohibited. I know the route to it, but sorry, you can't get to me. I'm not going to let you come through. Now, this sort of leads on to our hardening a bit later on. When we say, okay, if I was someone who was actually looking at your network and trying to scan and work out what was going on, I could say from that, okay, I know that I can get to that host through that interface, but there's an ACL that's partially blocking me. Okay, so that's giving me some information, which I may or may not be able to use later on down the track. So this is where we do our hardening later on, and we turn off things like ICMP unreachables. So in that case, if I was to turn off ICMP unreachables on the HQ router over here, router B, then I would not be able to, all I would get is 5 full stops on my ICMP replies. So then I go, well, okay, I don't know whether I can route, I don't know whether there's a firewall there, I don't know what's going on. Okay, so it's less information. So just something to keep in mind for later on. Okay, so as you can see, remember our principle of applying the ACL as close to the source as possible. Unfortunately, if we applied it to router A, which is as close to the source as possible because the loopback interface that we were coming from is sourced on that router, it didn't work. And this is because of the order of operation, okay? The way routers treat traffic initiated from themselves differently to traffic that passes through them. Okay, so in that case, placing it as close to the source as possible didn't work. But the key word is possible. Okay, it was possible to put it on router A, but it didn't work, so we move it to router B, which is still pretty close, but it's the next step removed, and bingo, everything works. Okay, because the traffic isn't initiated from the router, it's going through the router. So that's really something to keep in mind, particularly on the exam, if it gives you a question or a scenario where you need to block traffic from a router itself. Remember that you will get unexpected results if you place the ACL on that router itself, even though best practice says put it close to the source. Okay, doesn't always work, so you've got to be a bit careful. Okay, so let's just leave that window open, and we'll just pop that over here for a second, and we'll go back to our lecture notes. Okay, so that's our standard ACL, our extended ACL. Okay, so let's have a quick look at a more extended ACL. So in this case, extended ACLs, because they're more specific, we usually say place them closest to the destination. Okay, so you avoid this problem. So we're not even going to worry about router A at the moment. We're going to go back to router B. We're going to go into Ethernet 1.0. We're going to take off the little access list there, And we're going to show run, so I'll make sure it's on the right interface. We're all good. Okay, so now we're going to create an extended ACL. So what I want to do now is I want to create an extended ACL that will allow me to telnet in from router A from the Ethernet interface, but not from the loopback interface. Whereas at the moment, I can go from both. So if we have a look at the telnet command over here on router A, telnet, okay, we're going to go to, let's just go back to our diagram. Okay, so we're going to telnet to 172.17.1.2, but we're not going to go from the Ethernet interface, we're going to go from a source, and you can see there's a /source interface subcommand. So /source loopback 0. And there we go, bingo, we're in. Okay, so we can see at the moment we can go from there. We want to stop that, so we want to be able to, and I'll just prove to you that we can also go from the Ethernet interface. So we're in. Okay, and then we're back out again. Okay, so we can telnet from both interfaces. We want to try and stop that behavior. So to do that though, we want to use, in this case, an extended ACL. So again, IP access list. Let's have a look at the keywords. What do we got? We got extended, and we need a different number this time, so we'll go 101. We have a look. What else do we need to do? Okay, we just hit enter. Okay, we're in. So now we're into extended ACL configuration mode. So again, let's have a look at what there is now. Okay, so there's a little bit different. So what we want to do is we want to deny. We want to deny, what do we want to deny? We want to deny, let's say we want to deny TCP from the source address 172.16.1.2 source wildcard mask, so we'll put in everything, so just from that particular host, and then going to any destination, and what port are we going to use? Okay, so how do we do that? So, okay, so if we have a look at our options, okay, so what we want to do is we need to put in equal 25. Okay, equal 25. What am I doing? Okay, so telnet. Who could remember what the telnet port is? Does anyone know what the telnet port is? I'll give you a clue. Yeah, thanks, James. Correct. Yep, thanks, Wayne. Correct. Yep. Oh, yeah, okay, heaps of people know. Right, so 23, correct. If you don't know, though, you can always hit the question mark, and it'll show you a nice lot of names for you, as well as the actual port itself. So in this case, you can put in either 23, or you can put in telnet. Okay, either one. And then we want to permit. We're going to permit anything else. So IP from any source to any destination. Okay. Then we're going to go on to now, because this is okay. Now there's two. Okay, we'll visit that in a minute. So we're going to Ethernet 01 again, and we're going to apply the access group 101 in an inbound direction. Okay. So if we jump out and we show IP access list, okay, there's our two access lists. Okay, so we've got our standard access list there, and we've got our extended access list there. Now if we have a look at show IP int Ethernet 0/1, we will see what access list is set. So the inbound access list is set to 101, and the outbound access list is not yet set. Okay, fine, good. So now let's see what happens. Is that going to work? Well, tell me, is it going to work? Is that going to produce the desired effect? Let's have a look. So we're going to go from the source of the loopback 0. Okay, destination unreachable, gateway or host down. Okay, So that's a message it gives me on my initiating. On the other side, it says administratively prohibited, unreachable. So again, it's sending those ICMP unreachables. Let's see what happens if we just go from the Ethernet interface. There we go, we're in. Okay, so as you can see, that provides exactly what we wanted. So you can see here we've got IP match, so one match for that rule, so coming a telnet coming from 172.16.1.2, and 34 matches coming from everywhere else. So why it's saying 34 matches is obviously once you've established the telnet connection, you've got packets going backwards and forwards. So that'll match on all those as well. Okay, so that shows us how we can do our extended access list. Remembering that we've always got to put in at least one permit somewhere in it, and that their numbers are ordered the statements are done sequentially. So if, for instance, I'd put in the IP any first and then put the deny after it, effectively nothing would have happened. Okay, so you've got to be careful the way you put in the order. You've got to be careful about which direction you put him in on, and as you saw before through the examples, you've got to try and make sure that you put it on the right router as well. So it's not always just as easy as saying put it closest to the source. Sometimes it is, sometimes it isn't. Okay, so you just have to be a bit careful of that. Of course, the other way we could have done that as well is we could have done this. So if we go into int 0/1, compilate first, Matthew. So int 0/1, and we go no IP access group 101 in. Okay, so that now takes the access list off. Yes. What we could have done is gone into the VTY lines themselves. Okay. And in this case, the keyword is IP access. Unless I'm very much mistaken. Let's have a look. IP. Oh, there you go. Look at that. There it is. Access class. So then we put our access list. Now in this case we could just use a simple access list if we wanted to. Or we could, well, probably would just use a simple access list. Access class 1, and that, sorry me, inbound direction. Okay, so that will now also stop router A from the loopback being able to get to the telnet line. So you can see I could either apply it to the interface or I could apply it to the actual telnet lines. So generally if you're trying to restrict telnet access to a particular router, you would generally put it onto the telnet line. That makes more sense. If, however, there was a transit router in the middle here that we were trying to block telnet through, then obviously you'd put it on either one of the interfaces depending on which direction the traffic was coming from. Okay, so there's two different ways you can do it. All right, so let's have a look at what our next what next section is. So a standard ACL we've looked at, extended ACL we've looked at. Okay, so the port operators. Okay, I didn't use HTTP today, I was using telnet. But we used the equal sign, if you remember the EEQ operator, to say equals telnet. So there's several other operators available as well. So as I said, EQ matches a specific port. GT matches all ports greater than the port specified. LT matches all ports less than the port specified. NEQ, everything except that port. And range gives you a range. So if I was to give you an example, let's have a look at the example. So we go IP access list extended, say 102, and we go permit TCP any. Okay, and then we have a look at the operators there. So we've got our EQ, our GT greater than, our LT less than, and not equal to, and our range. Okay, so what that looks like is, so TCP, so we could say equals 25, so equals SMTP. We could say that. We could then say greater than, say 1024, so all ephemeral ports. we could say less than, and again some of these will overlap, but I'm just doing them as a purpose of an example. So anything less than 13,000. Okay. We could say anything that's not equal to 23. Okay, so anything other than telnet. And the other point is we could put in range. Okay, and in the range you can put in a huge range. So you can see the start number can be 0 to 65,535. So if we wanted all ports, we could say bingo like that. And that's basically the same as putting in an IP and any. So again, that's not necessarily how you would use them, but it just gives you an example of what those operators are and how you can use them. Okay, so examples, here we go again. So match ports greater than 50, access list 101 permit TCP any host, that IP greater than 50. Match ports less than 1024, okay, so less than the ephemeral ports. Ports not equal to HTTPS is another example, and ports between 21 and 80 inclusive. Okay, so that range is inclusive. The other thing you can put on the end of your ACL is this keyword log, and that will keep a count of the number of hits. Now a lot of iOS will do that by default anyway. You'll see it earlier, I didn't put that keyword on, but it will automatically keep a count of how many packets. The other thing you can do is put the log input keyword, so log-input, and this will include more detailed information including the source MAC address and the inbound interface of where the packet came from. And that can be useful for troubleshooting or when you've got security incidents. Okay, but again, once you've done that, it's also a good idea to ship that detail off to your log server, your syslog server somewhere, so you keep a track of it, because obviously the router buffer will eventually fill up if you're getting hit a lot. Okay, so named ACLs, two advantages over numbed ACLs. You can use identifiable names and you can remove individual lines, but you can't insert them. Okay. Standard name list, so there's an example, IP access list standard, deny telnet, deny 172.18.00.00255.55, so anything from 172.18 network, and then permit all other traffic. Okay, extended name access list, so IP access list extended, permit web, and then you just use the extended syntax as you do with a numbered access list. So the only difference really is it's named. Instead of putting a number there, you put a name. We've got our permits, we've got our denies. Okay. Okay, so NAT. Let's have a bit of a quick look at NAT. So just let me close my notes here. Close down our windows. That's better. Okay, so if we have a look at our NAT. So, let's have a look. So the rapid growth of the internet basically resulted in a shortage of available IPv4 addresses. So in response, at one time, there was a specific set of the IPv4 address space that was designated as private, okay, to temporarily alleviate this problem before we sort of got around to coming out with IPv6 and getting that rolled out. So those private IP addresses were the RFC 1918 private IP addresses. So they are not public addresses. They can't be routed on the internet. You must use NAT to route to the internet. So NAT's basic job is to translate between the private and public addresses. Okay, so it allows a host configured with a private address to be stamped with a public address, thus allowing that host then to get out across the internet. And then it's also possible to translate multiple private addressed hosts inside to a single public address, which then conserves the public address space, and we'll see how that works shortly. It also provides an additional benefit, which is, there's quite heated debate about this, about hiding the specific addresses and addressing structure of your internal network. So there's some considerable debate on whether that represents a approach to security or whether it's security by obscurity, whether it's a good thing or a bad thing. Okay, so and everyone will have a different opinion on that. I don't have any particular opinion on that at all. I think it can be useful in some ways and in other ways not quite so useful. So I'll leave that up to you to decide whether you think that's a good idea or not. Okay, not required with IPv6. Well, we'll wait and see on that. We didn't think it was going to be required with IPv4, but obviously we've used bucket loads of more IP addresses than we ever thought, and even though IPv6 is a massive, massive, massive address space and will allow us much more connectivity than what we've got now, who knows? Who knows whether it'll run out in the end or not? Who knows? Okay, so types of NAT. There's static NAT, which is a one-to-one translation between two addresses or between a port on one port, between port 1 on an address to the same port on another address. Okay. See how that works in a sec. Dynamic NAT uses a pool of global addresses to dynamically translate outbound traffic. And then you've got NAT overload, or PAT, which translates outbound traffic to unique ports from a single global address. Okay, so dynamic NAT is taking a pool of addresses, so more than one, and dynamically translating your outbound traffic. NAT overload is using one public address and putting all your private IP addresses behind it through that single address. Okay, so it uses the ports differently. So important terminology that you must know for the exam. So inside local. So this is the specific IP address assigned to an inside host behind the NAT-enabled device. Okay, and it's usually a private address. Inside global is the address that excuse me, the address that identifies an inside host to the outside world. Okay, so that's usually a public address. So essentially this is a dynamic or statically assigned public address assigned to that private host. The outside global address is the address assigned to an outside host. So that's usually a public address. So that usually is, for example, the web server or FTP server that you might be going to. And then lastly, there's the outside local. So this is the address that identifies an outside host to the inside network. And usually, quite often, this is the same address as the outside global. However, it is occasionally necessary to translate an outside or public address to an inside private address. Okay, but for simplicity's sake, it's generally acceptable to associate the global addresses with public addresses and the local addresses with private addresses. However, you've got to remember that public to public and private to private translation is still possible. Okay, so you don't always have to NAT from a private IP address to a public IP address. You can NAT from a private to a private or a public to a public. That's perfectly valid as well. It's just that the typical implementation will use public to private IP addressing. Okay. So let's look at the terminology example. So if in our little diagram here, we've got our hosts, our router A, which is NAT enabled, our router B, which is NAT enabled, and our host B. So where does the inside local, outside global, outside local fit into this? Okay, so if we consider traffic going from host A on the left here to host B on the right, the inside local address of host A will be 10.1.1.10. Okay, so that's its own local IP address. The inside global address, which if you remember is the private host's representation to the outside world, will be 55.1.1.1 because that is the address on the outside, the public side of router A, which is NAT enabled. Okay, so that's 55.1.1.1. Our outside global for host B is 99.1.1.1. You can see that over on router A, well, it's got router A, router A. Okay, that's interesting, isn't it? So router A, router B. We've got our static NAT translation here of 91.1.1.2 to 192.168.1.5, okay, which is our host behind here. So the outside global address from host A's perspective will be 99.1.1.2 because that's where I'm trying to get to. I'm trying to get to this host over here. That's its IP address. Similarly, the outside local is the same IP address. As we said before, it's generally the same. Okay. So static NAT configuration. We need to identify which interfaces are inside and which interfaces are outside. Okay. So we have our commands interface FA00 or whatever interface it is, IP NAT inside. So that automatically tells the router now that this interface is to be considered the inside interface from a NAT perspective. Okay, so we're expecting, in general, private IP addresses on this side, but it doesn't have to be, as we've seen. And then int ATM00 IP NAT outside. Okay, so why have I used those interfaces? Because that's typically what you'll see on like some sort of DSL service, home DSL service. Okay, so your internet fast Ethernet 00 will be your IP NAT inside. Your ATM, which connects to your DSL, will be your IP NAT outside. Map public to private IP addresses. So in order to map your public to your private, IP NAT inside. So we're going to NAT from the inside. We're doing source address translation. Okay, source. It's a static translation. The internal IP address, so the inside local, is 172.16.1.1. And the outside local is 203.193.205.50. So what that'll effectively do is create a static NAT entry for 172.16.101, and it will map it to 203.193.205.50 outbound. Pretty simple. Okay, a dynamic NAT configuration. Again, you need to identify the inside and outside interfaces, so the same as before. IP NAT inside, IP NAT outside. We then need to create a pool of global addresses. Now this pool can be as big or as small as you like. You can actually have one in a pool, although that then becomes a bit pointless because it then becomes the next version of NAT, but you can if you want to. So in this case the syntax is IP NAT pool, pool name, starting address 203.193.193.1, finishing address 203.193.193.50. So that means that it will use .1 to .50 inclusively in that particular pool for your natting. And then you use a net mask, just put the mask on the end of it. If you don't put a net mask in, if you just hit enter, it will use the classful net mask. And then we need to identify, so another use of ACLs, identify which addresses to NAT using an ACL. So in this case we go access list 10, so standard access list, yeah, permit 172.16.1.0, okay, subnet mask as required. Then we apply the ACL to the NAT pool. So IP NAT inside, so again this is done on the interface, IP NAT inside, source translation using a list, so match the list 10, so match the IP addresses in access list 10 and use the pool name, in this case this one up here, to actually NAT the IP addresses. Okay, and lastly the NAT overload configuration. So again we have to identify the inside and outside interfaces. We create a pool of global addresses. We identify which NAT addresses to use NAT, and we apply it to an overload interface. So as you can see, the only difference is we IP NAT inside sources 10 pool interface ATM00/overload. Now, this second step here is completely optional. Okay, you don't have to do that second step at all. You can, but you don't have to. If you don't do this second step, all that will do is overload on the ATM00. Okay, and then we have our troubleshooting NAT, useful basic commands, show IP NAT statistics, debug IP NAT, be careful on heavily used NAT routers, show IP NAT translation, and clear IP NAT translation. Okay, now let's have a look at the lab. Let's have a look at our NAT lab and it'll all start to come together a bit more. So lab 2.2, connecting to the internet. Okay, let's have a look. Okay, so what we might actually do is actually step through this lab so you can see exactly how the labs work, and you can see the benefit of them, because it's basically what we've been talking about anyway. So let's have a look. So let's show our steps. So what we're going to do here is, in this task, you will configure an IP address on the internet facing of the branch router. You will also configure a static default route on the branch router to reach the internet networks. You'll then verify connectivity between the branch router, HQ router, and the server. Okay, so we need to access our branch router, so we're going to jump on our branch router here. Come on, branch router, there it is. Okay, so we're in enable node. So we go show IP int brief, because it says you should see that only Ethernet 00 is up and configured with an IP address. Okay, there we go. Okay, I've been in earlier. Alright, so good. I wasn't sure whether I'd done that. I have. So what we're going to do is I'm actually going to step down to the actual bit about NAT. Okay. So I'll show you some cool things about these labs. Okay, so what we've got at the moment is we have our branch router, and if we have a look at our HQ router, so you can see on our branch router here we have an internal address 10.1.1.1 on the Ethernet 00. We have a public IP address which has been received by DHCP, okay, on Ethernet 0/1. It connects to the HQ router over here, and then we've got our loop back over here. So if we see if we can ping our HQ router, we can, we're all good. So what we're going to do is now we're going to use some NAT. We're going to configure some NAT. So access the branch router. We're going to configure a standard ACL that allows the 10.1.1.0/24 network. Use 1 as the ACL identifier. This ACL will be used to define networks that are eligible for NAT translation. So again, this is an identification NAT, identification ACL. Now the cool thing is, if you weren't sure how to actually do that, you could use your mouse and just hover over that question mark, and it'll tell you how to basically do it. Okay, so access list 1, permit, blah blah blah, where it goes. So we can go access list, got it. Doesn't stop you from doing typos, obviously. Access list 1, again, we'll use a question mark again if you can't remember, so permit, and we're going to permit 10.1.1.0, and now notice you can put in /NN, / notation, or ABCD, okay? So just in this case, we'll put in our normal wildcard mask. Okay, so we've done our ACL. Okay, let's just put that guy down here for a minute. Then we need to create a NAT pool with the following parameters. So pool name NAT pool, starting IP address, ending IP address, network mask. Okay, so again, if you're not sure, you can have a look. Okay, IP NAT pool, yep. Okay. So we'll create it. IP NAT pool, again, if you're not sure. Okay, question mark, so NAT _ pool. Then we have, what do we have next? Okay, so start IP address. So again, you can always use the question mark to help you. If you've got a basic idea of what you're doing, you can always use the question mark, and it will give you the answers that you need. Okay, and then what do we do there? Okay, we got net mask. Again, you can put in the prefix length if you wanted to do that as well. And then we're going to put in our subnet mask, 224. Okay, now is there anything else? Okay, a few things, but for standard, no. Okay, done. So I've done a pool. Then we're going to configure, step 4 we're up to, configure the Ethernet 00 interface as the IP NAT inside. Okay, so int E00, we're going to go IP NAT inside. And that's it. So that then signifies to the router that this Ethernet interface is the inside interface. Okay. Now it does take a while to respond. Even on a real router, it'll take a while for that to respond. Okay. So don't worry about that. We're now going to up to step 5, which says configure the Ethernet 01 as the outside. So again, we go into interface mode and we go IPNAT outside. Okay, so that's the easy bit. Okay, now let's start to get a little bit more tricky. So what do we got to do here? It says configure a dynamic source NAT rule that will translate inside hosts into the IP addresses that were defined in the previously configured NAT pool. Okay, so the inside addresses we're going to translate using the NAT pool. Use the ACL to specify hosts that are eligible. So again, we're going to use that access control list to identify which IP addresses we're going to use. So how do we do that? Okay, so it looks pretty simple. IPNAT inside source list 1 pool NAT. Okay, so let's do it. So we're going to IPNAT. Okay, again, question mark. So inside interface for address translation. Yep. So we're going to use we're going to translate from the inside. What am I doing? Okay, so IPNAT. What am I doing? In the wrong mode. Sorry. Okay, IPNAT. Let's have a look. Okay, what are we going to do? Inside address translation. Yep, we're going to inside address translation. Then what happens? Source or destination address translation. Well, we want to do source address translation because we're coming from the inside to the outside. So we use our source address. We use our list. Okay, so can we remember what the source list was? Okay, it was list number 1. Okay, so that's saying use the ACL number 1. And we're going to put it into the pool. We're going to overload it on the pool, nat underscore pool. Okay, so that now has now created our nat pool. So if we use some of our troubleshooting commands, so if we go shape IP nat translation, let's see if there's anything in there yet. Okay, nothing in there, nothing in there. Okay, so now it says step 1. Access PC1 and establish a remote telnet session to this server. Okay, now it says PC1, but I'll tell you now it's not a PC, it's actually a router. So they're sort of cheating a bit here, Cisco. So you still use the same commands as you would for a router. So 172.16.1.100. We're going to telnet. Okay, it's trying. It's open. Okay, now it's on. Now if we go back to our branch router and we go show IP NAT translations, there we go. We can see a translation has now been built. So the inside global address, remembering that is how the inside host appears to the outside world. So it's 209.165.201.5. The inside local address is 10.1.1.100, so that's the IP address of the PC1. The outside local is 172.16.1.100 because that's the server I'm trying to get to, and the outside global is the same. Now in this case, these are private IP addresses, just for this topology. But it could well be, generally they would be public IP addresses, okay? So don't let the private and public IP addresses confuse you. It doesn't matter what you NAT. You can NAT from one to the other freely, okay? But for the purposes of the internet, you can't get out on the internet if you're using a private IP unless you NAT. Okay, so we've seen that the translation is now built. Excellent. Okay, verify the user connection to the server, show the user command. We're not going to worry about that. And return to the branch router. Okay, so return to the branch router. Okay, so the translation will still stay there until such times it times out, or if I go clear IP NAT translations, up, got to learn how to spell properly, people. Trans and star on the end to clear them all. And I go show IP NAT trans. There's now nothing there. Okay, so it's gone. So now we're going to configure. So that was our dynamic. That was our dynamic NAT. Yeah. So we had a pool of addresses, one address to one address, but it's still using a pool of IP addresses. Now, an interesting question is, if you have, say, 100 internal addresses and you've only got 50 in your pool for external, what happens when you run out of IP addresses on your NATing? Well, the answer is it stops. Okay, so your NAT will stop. unless you also have a overload. Okay, so in this task here, we'll configure dynamic NAT with PAT on the branch router to translate the IP address of inside host to the public IP address of the branch router. Okay, so now we've got to remove the previously configured dynamic NAT rule. So, all right, how do we do that? So let's have a look at run. So the easiest way to do that. So we don't want to change the IP NAT inside or outside. Okay, so the easiest way I like to do this is go to comp, type in no, and then go. Oh, I don't believe it. It won't let me do it. It won't let me copy. I don't like it. Ah! Usually you'd go in there and you would just go copy and then paste it down to that line and you're done. In this case here, obviously it's not going to let me copy unless I copy all, which I don't want to copy, so we'll just type it in manual. Okay, so that's now taken out that NAT. Okay, the pool's still there, but the actual NAT rule itself is gone. Christian, good question. Oh, no, sorry, that's one of the old questions. Okay. All right. Keep moving on. So this time, we've removed our previously configured NAT rule. This time we want to configure a dynamic source rule that will translate inside hosts into the IP address of the router on the outside interface. So how do we do that? Remember, if we looked at our previous slide, it was actually fairly straightforward. So we do our IP NAT inside source, list 1, interface, Ethernet 0, overload. Okay, so let's have a look at that. So we go IP NAT, what was it again? IP NAT, okay, we're going to do inside NAT. We're going to do source NAT, because we're, again, translating the source. We're going to use an IP access list to define which ones they are. We're going to use access list 1. We're going to overload it onto interface Ethernet 0/1. And as we said, we're going to overload it. Okay? Bang. So that will now, so if we go show IP, whoop, trans, what's there? Nothing. Okay, so now we go back to our PC1. Okay, and we try to telnet again to 172.16.1. Okay, so we're open, we're on. Show IP NAT trans, and there we go. We can see now same translation is built, so the translation still looks the same. But when we go over here, we can see, if we use our show users command, that we've got a telnet connection from 209.165.201.1. Okay, so it's overloaded onto the IP address of the branch router, 209.165.201.1. So there we go. Okay, so that shows you how your PAT and dynamic NAT works. Okay, excellent. So I'll just jump out of that. You don't need to go any further there. Okay, so DHCP servers. Let's have a look at our DHCP servers. Okay, let me just refer to my notes. Righto. Okay, so DHCP is obviously fairly important for larger networks. Although in most larger networks, enterprise networks, you're going to have specific DHCP infrastructure. So DHCP for servers, for routers, are often used in either smaller type networks or in smaller departments that don't necessarily, they don't have the infrastructure or the resources to run their own specific DHCP servers. Or for things like wireless hotspots, for instance, you might serve your IP addresses off your router. For phones, often in IP telephony environments, so we'll run DHCP addresses off the server, off the router. So in order to hand out the addresses of the DHCP protocol of choice, leases out client addresses. There's 4 steps to the DHCP process which you need to be generally aware of. There's the DHCP Discover, the DHCP Offer, DHCP Request, and DHCP Acknowledgement. And all of these are, so basically stepping through each of those, when your client first boots up, so whatever it is, PC, smartphone, whatever it is, it'll broadcast for a DHCP Discover message, searching for a DHCP server. Right? So if a DHCP server exists on the local segment, so it's always local, so remember routers prevent broadcasts, and this is what DHCP Discover is, a broadcast. So if there's a local DHCP server on that segment, it will respond with a DHCP offer, and inside the offer will contain an IP address, subnet mask, gateway, and any other options that you might want to set on your DHCP server. So once a client receives that offer, it will respond with a DHCP request indicating, yep, I'm happy with that. Can you please put that into your database as being assigned to me? And then finally the server will respond with a DHCP acknowledge, acknowledging the client's acceptance of the offered protocol information. So by default, a DHCP server will usually lease for 8 days. As part of the protocol, once 50% of that lease expires, the client is obliged to renew that lease with the same DHCP server. Okay, so not a different DHCP server, the same one. So after 4 days, it'll try again. And if successful, then it'll receive that for a new 8-day lease, so it keeps renewing. Okay. If, however, it's not successful, so it can't contact the DHCP server, the client will continue to attempt to renew until 87.5% of the lease is expired, and then once this threshold has been reached, the client has to find another DHCP server to try and get an IP address from. Okay, so it's just a little bit about the protocol that you sort of really need to know. Okay, large networks obviously need DHCP servers. Well, it's the same slide again. What are we doing there? Okay, so DHCP config. Let's have a look at another lab, another quick lab here. Okay, so this time 4.2. Okay, so here we go. We got, okay, so as you can see on the diagram here, we've got our branch router, which will run the DHCP server. We've got our DHCP clients, which are actually routers. And then lastly, we're going to configure the DHCP relay agent. Well, it's called a relay agent, but you'll see the actual configuration is a little bit different to that. And what that will do is instead of serving the DHCP addresses from the branch router, it will pass them on to the DHCP servers. So let's just have a look at what we've already got. Come on. Doesn't want to talk to me. Okay, let's try the PC. Alright, our lab's playing silly buggers, so let's just exit that for a second. Probably more to do with my web browser than anything else. Excuse me. Let's go, guys. Stream web, it's better. Oh no. Our lab's completely hung. That's not good. Okay, so let's just bear with me for a sec. I'll just log out. Okay, we'll see if there's anyone in here. See if there's a DHCP one in here. Implementing IPv4 DHCP services. Here we go. Just use this one. There's always a way around it. Don't you love online lecturing? Okay, wow. This looks like a ripper. Okay, this is a much better lab. Okay, so connect to branch and enter the enable. No, okay, well, we don't need to have that, I'm sure. Okay, so looking at topology here, as you can see, this is quite a substantial, bigger topology than the other one. Okay. Actually, this one looks a little more advanced than what I want to cover. So we might just jump out of that. Try this guy again. There we go, now we're cooking. Well, we were cooking, maybe not. Well, we're not having good luck with the labs today, guys. But that's some magic of Java. Last time. Okay, if it doesn't work this time, we're just going to have to push on. Yay! 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 Yeah. Maybe not. No. Okay, we're in trouble. Alright. So it looks like our lab is not going to work today. So, might just, as a last chance, see if we can exit our lab system. It has been sitting there in the background for a while, so that's always a bit of a problem. Okay. Let's have a look. No, okay. No, it's going to die on me. Not going to be happy. Okay, so what we'll just do, if we quickly have a look at the steps. Okay, so on the branch router here, basically the idea is you create a pool of IP addresses. Okay, so if we have a look at the DHCP pools, so it says configure a DHCP pool named VLAN 10. The list address should be part of the 10.1.10.0 network. So the way we do that, let's have a look at some notes. Let's have a look at some notes instead. So we'll do it here, so at least you get an idea of what the configuration is. So it would be IP DHCP pool VLAN 10. Okay, and we can see from, if we have a look at it again, if you need any help, look at the cheat sheets. Okay, so the general format is IP DHCP pool and then the name of the pool, and then you type in network 10.1.10.0/24 in this case, because it's asking us to allocate addresses out of 10.1.10.0 network. Then it says determine the router interface IP address. Okay, so in this case I know that the IP address is, so it's default, the keyword is default router 10.1.10.1. Okay, and then we're going to use that for our DNS as well. So in this case the keyword is name server 10.1.10.1. Okay, and that would then be, and then you would type exit, and that would get you back out to your configuration mode. So that has created the pool, the network 10.1.10.0. Okay, step 3 also says change the lease time to 2 hours. So that command is lease, then the first, there's 2 digits to it. First part is number of hours, some number of days, second part is number of hours. So we're going to say lease 0 days, 2 hours. Okay. So that will then, that then creates your pool. Okay, so that's how you create a DHCP pool. To then start using that, all you really need to do is connect DHCP clients to that interface. So in this case, if we'd put that configuration onto the branch router here, these hosts here would automatically start picking up addresses through that pool. Okay, and the way we would see that is by typing in the command show IP NAT, DHCP bindings, show IP DHCP bindings. Okay, and that would then give us a list of addresses internally, addresses, MAC addresses of the clients, IP addresses that they've been assigned. Okay. Now, if for instance, so by default, what that's going to do is it's going to allocate everything out of the 10.1.10 network as valid client addresses. So that would be 10.1.10.1 to 10.1.10.254. Okay, obviously we don't want to do 1 because that's actually the interface of our default router. So we have to do some what's called exclusions. And where we do those from is not within the IP DHCP pool as you may expect, but it's actually from just default configuration mode. So that would be in, if we look like router A hash comp, at that comp there. Okay, and the way we do that is by IP DHCP excluded hyphen address, starting address, so 10.1.10.1 to 10.1.10.49. Okay, so then what that would do is that would not allocate anything from 1 to 49, so the first allocated number would be 10.1.10.50. If, for example, I wanted to only allocate a numbers between 50 and 100, I would do one excluded command that I've done there, then I'd do another one, IP DHCP excluded address 10.1.10. Say 100, 101 to 10.1.10.254. So what that effectively says is only allocate addresses between 10.1.10.50 and 10.1.10.100. Okay, and that's all there pretty much is to creating IP DHCP on your server. Okay, so fairly straightforward. You can also put in a number of options. Okay, so your options may be, say, if you were to say for your DHCP, for your IP telephony phones, you might put in option 150 and 10.1.10.2 might be your call manager or your PABX. Okay, so what that's saying is I will send an option 150 to the DHCP client and tell it that if it requires an option 150, that 10.1.10.2 is the IP address that relates to that option. And you can put in any number of options. Okay, there's no limit on those. So that's the same sort of thing as what you would do with your Windows DHCP servers as well. Okay, and that's pretty much all there is to DHCP. That's assuming it's on the router. If, however, you want to, as this we could have done if the lab had worked, configure the DHCP relay agent, what we need to do is go onto the interface, so in interface configuration mode, so we'd type, say, F interface 0/0, okay, which would then change the prompt to router A, pound conf interface, like that. You could then type in IP helper address and then type in the address of the DHCP server, which might be 10.1.20.10 in this particular case. Okay, so what that then allows you to do is that would then mean that any DHCP requests that came in on this interface, which is interface E00, the helper address would say, the router would say, okay, I've got a helper address, so I need to pass those broadcasts as a unicast through to our DHCP server. And the router would do that on your behalf. Okay, so, but again, it doesn't send it as a broadcast, it sends it as a unicast, because remember, routers don't like sending broadcasts. Okay, and that is pretty much DHCP in a nutshell. That's pretty much all you need to worry about for the exam. So understand that you can create pools, You've got an IP DHCP helper address command that allows you to pass on DHCP broadcasters unicasts, and remember that particularly that it will convert a broadcast to a unicast, and that you can also exclude some IP addresses. So I'd be very surprised if you didn't get a question which asked you to create a pool, change the lease, exclude these addresses. I'd be very surprised if you didn't get something like that. Okay, and lastly, last topic for this morning, basic hardening. So things like add password protection. Okay, so don't just leave your router, your telnet options and your console set as no password. So put a password on it, put a secret password on it. Okay, so you can't just connect to the console and get in. Enable SSH. Okay, instead of using telnet, use SSH. Okay, which is of course encrypted. Configure a login banner. So login banner is a bit of a contentious one, but generally they're considered a good idea. So put a login banner and say, when someone tries to log in, say, warning, this is a protected system. Don't come on here unless you're authorized. Limit your access with an ACL. So that could be an access list to stop you from getting management access. So say on the VTY lines, or it could be permitting telnet through your router as well. Disable unused legacy services. So these are things like TCP small servers, UDP small servers, service pads, all sorts of different services that generally nowadays by default they're turned off, but just check anyway. If we go back to our lab, and not that particular one because that doesn't work, let's see if we can just get onto a router somewhere. Get onto this one here. Oh, not having any luck at all. Okay. Let's just get that. Okay, so disable unused legacy services, shut down unused interfaces. Okay, so if you've got a 4 ports on your router and you're only using 2, shut down the other 2 so that people just can't come in and plug into it and away they go. Enable port security on your switches. Okay, now again, this is a bit of a contentious one. Port security has been fought with a few problems over the years and sometimes doesn't always work, and it can be a bit tricky if you've got IP phones as well. Basically, the idea is of port security is that you enable each port to only allow a certain amount of MAC addresses. If more than that amount of MAC addresses tries to get in through that port, it means that you've got some other switch or hub device connected to it, and it will lock down the port. You can also use sticky MACs. Okay, so you can actually configure a MAC address on that port and say anything else other than this MAC address is not available. It's not allowed to connect to this port. So you could come and connect your laptop. Someone can come in and connect their laptop to it. No, won't work. Okay, because it's restricted to a specific MAC address. Disable CDP. For people who work in enterprise, CDP is an absolute boon. For people that work in service provider, generally it's turned off because you don't want anyone else being able to get any information about your router. CDP is great for troubleshooting in that you go show CDP neighbor and you can see the type of device, iOS it runs, the IP address, all that sort of basic information, which is great for troubleshooting or for building a network diagram. But in terms of security, it's a bit of a risk. So generally we'd say basic hardening, turn CDP off. And configure NTP. Okay, configure NTP and configure your syslog servers. So configure NTP, so make sure that your routers, because there's nothing worse than jumping onto a router, doing a show log and finding all these security events and thinking, oh wow, we've had a security event, let's try and match up what time it was, and you look at it, no NTP, okay, it's set to default clock, you've got no idea of when it happened or how, you've got to really work hard to try and match things up. So configure NTP so that you know exactly when things happen that show up in your log. And then of course configure your syslog or SNMP logging. Okay, so ship these things off. Ship these things off to a syslog server or an SNMP server somewhere. Because obviously your routers have got a finite amount of buffer space. Once that fills up, you haven't got anything. So make sure you ship it off to somewhere. Now all of these things here are not necessarily things you will see on the exam in terms of having to type any configuration in. In fact, most of them are, other than the ACLs and putting a password on, I'd be surprised if you got any specific questions asking for configuration. But you will be asked about the theory of them. Okay, so again, have a look at the readings that are on the website and think about some of these things. So think about how what NTP, so Network Time Protocol, if you don't know. Logging, you've got your syslog and your SNMP are the two main options. Okay, so think about them. I was going to do a lab, but it looks like the labs are playing up for some reason today, whether that's the labs folder, whether it's just my version of my web browser that's playing off. They were working the other day, so there may be something not quite right. So, but again, it was just skipping through briefly, so showing you some of these things that we've just talked about. So it's not really a huge deal. Okay, so in terms of today, that's the end of today's lecture. So thank you for attending for all those. Next week we'll be talking about troubleshooting. Okay, so I'll have some devices here and we'll have introduced some specific problems on it. So this one will be it'll be more of an interactive thing next week. So I'll be asking a lot of questions and asking you to identify what you think's wrong. So you need to probably make sure that you cover all the material that we've looked at so far, and just have an overall view of it. So we'll look at some routing, we'll look at some switching, we'll look at some security like we did today. There'll be some static routing, some dynamic routing, some NTP, maybe some syslogging. Okay, so we'll look at all those different things and see what's working and what's not working and how we go about fixing that, and the sort of commands mainly that you use to troubleshoot. So there'll be some NAT as well. Okay, so the sort of commands you use to troubleshoot NAT. Okay, so if you have a look at some of the readings which are on the Moodle site, so that's probably timed out. So I'll just log in again and just show you where that is. So all this sort of stuff, I'm getting plenty of questions about people about where is resources, where is this, where is that. Everything's on this Moodle website. Okay, so under the resources tab on each week, there's a number of readings for each one. Not so much the IP addressing for next week. Resources for introduction, basic networking a little bit, certainly for routing and the IP services and security. If you make sure you have a look at those and have a look at any reference there is to troubleshooting, then they're the sort of commands that we're going to be using next week. Okay, the week after that we will have our practice exam. So I might run a short webinar just to give you a bit of an idea of the sort of questions that we'll be looking at in the exam. But that exam will go live the Monday of week 6. Okay, so I'm not sure what date that is off the top of my head. So week 6, I think that will be around about, it'll be the 21st of October. So the 21st of October at 9 AM Victorian time, that exam will go live. It'll be open for a week. So basically I'm going to set it up very similar to a CCNA exam. It will have 80% pass mark on it. You'll be able to do the question once. You won't be able to go backwards and forwards. You will not get instant feedback, but you will get feedback on each of the questions and whether they're right or wrong at the end of the exam itself. Okay, so for this week, that's it. Hopefully you'll return at 10 AM next week when we'll do our troubleshooting for week 5, and then all we've got left is a practice exam. So thank you for your attention, and we will see you all next week. Bye for now.